Ultra-reliable low-latency communication, URLLC, constitutes a key service class of the 5th generation and beyond cellular networks, and is about taming the tail of reliability and latency under the uncertainty arising from the stochastic nature of wireless communications. Most URLLC use cases are very different from conventional human-type communications. Indeed, traffic with smaller payloads and sporadic arrivals, large device density, and stringent service demands are characteristic of URLLC use cases. Designing and/or analyzing URLLC systems mandates adopting a vastly different set of statistical tools and methodologies. In view of this, a group of our 6G researchers put together a comprehensive tutorial on several statistical tools and methodologies that are useful for designing and analyzing URLLC systems. They overview the frameworks related to reliability theory, including the concepts of availability, reliability, maintainability, and others, together with assessment tools such as structure functions and reliability block diagrams, and Markov models. Moreover, they discuss relevant inequalities and distribution bounds useful for URLLC design and analysis. Tail approximations based on extreme value theory, and risk assessment methods. An entire section is dedicated to rare events simulations, which are intrinsically related to URLLC problems. For instance, target error probabilities in URLLC setups are significantly small, even smaller than 10 to the power of -5, thus challenging conventional Monte Carlo estimation and simulation methods, and motivating the exploitation of the tools overviewed in the paper. In addition, since ultra-low latencies are a must in URLLC, the finite block length coding theory, including the description and performance of practical codes, and short packet protocols were thoroughly reviewed. Queuing theory and information freshness frameworks, such as the effective capacity, stochastic network calculus, and age of information were described within the URLLC context, and the statistical interplay between availability, latency, and power consumption was characterized. They also discussed tools for the design and analysis of large-scale URLLC, such as meta-distribution, clustering, compressed sensing, and mean-field game theory. Finally, a section of machine learning for URLLC is delivered with some insights on when to apply machine learning, applications and technologies, meta-learning, and time series for intelligent resource allocation. Throughout the paper, they briefly review the state-of-the-art works using the addressed tools and methodologies and their link to URLLC systems. They also present and discuss novel application examples focused on physical and medium access control layers. The work in this paper is targeted toward graduate students, early-stage researchers, and professionals interested in getting a comprehensive overview of the statistical tools and methodologies relevant to URLLC, and will help foster more research in URLLC and its evolution towards next-generation wireless systems.